Hi, everybody. Happy Monday. Hope your weekend was good. So here's my next reaction video to what I saw you all do with this NFL Combine activity. Um, I s- so it was this like clip from this thing where they had a bunch of different athletes running, and people were like, "Why is there a person in a suit running?" and all that sort of stuff. So what I'm going to do is I'm going to talk about some of the interesting questions that people had. People definitely said that the equations part was the trickiest part, so I'm going to talk about how you could do that, and we'll look at some of the stuff that people created, and then I'll give you the code for the activity that I'm going to post as soon as I'm done with this video. So first of all, people had some questions, especially towards the end, where it was like, how would you solve this? How would you figure out when they'll catch up with equations? So I'll definitely go over that. Um, when we first looked at it, people were just like, what is going on with this situation? There were a lot of questions like that. Why is there a person in a suit running? He's one of the commentators, and usually he's sitting behind the desk, like talking about the things that the athletes are doing, but they always do this joke, apparently, where he like tries and does the 40-yard dash or whatever, like the athletes do. So that's why. Rich is slow because he's not particularly trained or fit, or, he's not at the same level as all these athletes. A lot of people asked like who would win or what happens next because it played half speed but only at the start. I think that was kind of like one of the questions that was sort of like begging like what's going to happen with half speeds. So people were like, I want to win. Who's going to win? I want to see it. I'm sure if you like went far enough along, you could see what actually happened. People also ask questions about the speed. Like they're like, exactly how fast is he going? What's his constant rate of change? People realized that was the speed. How fast is the football player running compared to the suit man? So like how much faster, like what are each of their speeds? People were asking some specifics, like how much faster is he? What's the meters per second? And then people noticed there was the little like counter saying their miles per hour, and they're like, but like why not do feet per second? Or if you noticed, a football field is usually in yards. So what you'll see is eventually we'll be using yards per second to sort of count that short distance. I don't know. Why would you want to calculate miles per hour? Why would they show us miles per hour instead of like feet per second or yards per second? I guess maybe we're used to comparing to how fast a car or something goes in miles per hour, so you can think how fast he would be compared to something you already know. But then if we want to like really specifically see where they're going to catch up, maybe we want the yards. And then I love this question, which was like, what if instead the other guy was twice as fast? Like, what would happen then? So this was probably my favorite question. Like, we had all these other ones, but then like, what if we changed it in this other way? What would play out? And maybe based off of what the details that we had, you could actually go there. So the first thing that this asked you to do was to graph it, and I saw all sorts of interesting graphs. A lot of people made graphs like this, different. They look different, but there's something sort of similar. They thought that Julio was way faster than Rich still, and that he would like be pulling away and getting. They'd start off at the same distance, but then he'd get farther and farther and farther. And then I had, oh, this is a little hard to see. Saw several people who like noticed that there was a delay in who was gonna go uh, when they actually set off. Like they were supposed to set off at the same time, but Rich is a little slow to get going. So some people had that delay, and people thought either they were going the same speed, or maybe like Rich was gonna very slowly catch up, but he wouldn't catch up within the distance of the like 40 yards. And then I saw some. So let me wait before I do that. Let me show you what it looked like when people sketch. So pretty much everybody was like, well, everybody thought that Julio was going to be faster and Rich wouldn't catch up. Almost everybody. If you look at, let's see, if you look at this, almost every single person said they weren't going to catch up. One person thought he would catch up at like the 38, and then I don't know why this one doesn't record. And then on their sketches, pretty much everybody was thinking like, okay, they're like getting farther, they're going at a constant rate. Some of us had them all starting at the same time. Some of us had like a delay before Rich set off. which means that if we went backwards, he would have a negative y-intercept. It'd be like he started farther behind and was running to catch up. And then, but then later on, after you saw that first bit where it played the first half of the video, and you could actually see the graph as it went, then suddenly everybody's graphs looked almost exactly the same. Like we were all drawing this graph. They showed us just this much, and then everybody was lining it up and making it all look the same. And we got pretty accurate, I think, to where it would actually go. So a couple of people still thought he wouldn't catch up. They thought maybe they would still be sort of parallel. But most everybody else was like, these are going together, and they're like slowly but surely going to catch up. So then a lot of people had guesses in the 30s or some in the 20s. Somebody thought he would catch him right at the 40. So that was really interesting. There were a couple of interesting, some really good annotations, clear annotations that people made. So let me take this one out. That way you can see people said like showed the spot where they actually caught up and then what their distance would be. So they showed where they got that number from. And then this person showed where they caught up, which would tell us their number. But also, I think this was one of the people who's really had some questions or was wondering about the speed. And so they were showing how, like, once they got that lined up graph, they could be like, okay, I can already sort of tell how fast they're going, which I thought was cool. So then it went into tables, like how do we figure out this tables? Later on, somebody pointed out that you can see the constant rate of change by the number. You can see the exact numbers. And so then you can continue it out. But you still have to kind of understand the question in order to really use it. The way that people used it was by looking to see when their distances were basically the same. Like this person said, hey, at 7 seconds, they're like basically at the same spot. Julio's maybe just a tiny bit ahead. I love these specific details. And this person said 8. I think they meant like 8 seconds, not 8 yards. Because they were looking at the amounts and they said, well, look, Julio's ahead there. Here, Rich has passed him. So it must have happened there. Interesting. I wish I could point out on the screen. But so like seeing that Julio was ahead, but then Rich was ahead, it had to happen somewhere between 7 and 8. Some people guessed where that was happening. So then, this is annoying. People pointed out that with the equations, you can plug in numbers and see exactly where things happen. So this person said they plugged numbers into the equations, those 2 equations, they plugged in numbers for the time, and they saw how close they could get to making them be the exact amount. They said 38 seemed to be what it was. And then another student showed, this is a student who was thinking about that 8 in the table. They were like, hey, look, we're just looking for Rich's equation to equal Julio's. Rich's distance to equals Julio's distance. So then people also had some other ways of using the equations. And I know people had questions about this. So you could do something like this, where they, show me the thing. Okay, I'm gonna have to pause. Okay, I'm back. So one student showed how they like tried solving the equation step by step. We're going to talk about that in a second. And another student did a really great job of describing it. They said they did basically the same thing. They used this equation, and when they solved it, they got 7.37, and then you substituted in with t, and they both come out with the answer of 35.36 as the answer, or as like, and they're both very close to being the same. So I thought that was a really clear explanation of one of the ways that you could use the equations. So let's just take a look at these equations right now, like made them in a Word document. So we've got Rich's equation here. We've got Julio's half-speed equation here. We know that somebody pointed out, like in the tables, we can see here's the speed that Rich is going in, his yards per second. 6.2 yards per second is our slope times the time. And then we can see his behind start, his y-intercept is -10, which means that if he'd been running that whole speed instead of like waiting to start, then he would have started 10 yards behind. And we can see that at half speed, Julio's going 4.8 yards per second. So what would his actual speed be? So anyway, if we're using that, having the equations be equivalent thing, we can take either one of the equations, and then this equation says that D equals 4.8 T. So I can take what D equals and I can substitute it. Here we see this D, we'll take what D equals from this equation and replace it with 4.8 T. And then the next thing we can do is subtract 6.2 T so we can get rid of it. But in order to get rid of it here, we need to take it off of both sides. So we want to get rid of it here, that way we have just the variable on one side. So if we subtract 6.2 T from both sides, then on this side, we will just have, that because this will have been subtracted away. But in order to subtract it on the other side, 4.8 minus 6.2, we're going to get negative 1.4 T. So we're almost done. Here's our variable T. We're trying to solve for it. So now we want to divide both sides by negative 1.4 so that we get rid of it down to just what T equals. Stop. So now we have T equals, and if we're going to divide on this side, we'll have just 1T, which is good, the 1 time. On the other side, we're going to get 10.33 divided by 7.37, 7.38. I'm in a negative dividing into a negative gives us a positive. So wait, what does this mean? I thought we were getting numbers like 30 or 40 before. But let's take a look at what these variables in our equation actually mean. Let's define them. So D is the distance they're at, or each person is at, in yards. And T is the time that each person is at that distance. And this is in seconds. Defining our variables tells us now that when we go down and look at this T, we know that this T is just literally saying that they're at the same distance, when the time is 7.38 seconds, because our units for this are seconds. So then we're not quite done, because our question was, like, where will they be when he catches up? Like, does he catch him before the 40 yards or does he catch him afterwards? So then we go back to either one of the equations, this one or this one, and we use it to figure out where they are at that time. So if our time is 7.38 seconds, then we can substitute that value for the time. And we get, I believe it's 35 point something. Yep, 35.41. 42, because it's 417. So then that tells us that they are both at 35.42 yards when they catch up. So if you take the elite athlete and you slow him down to half speed, then even if Rich gets a slow start, you can just barely catch him. So to summarize, we know about how to like substitute and put things in. You could also think about this like D equals D, distance equals distance. That would also work. Or we can do that substituting where we take what D equals in one equation and we put it in the other one. So then, so you could use this on your own if you like created some equations later. So then here were some of the situations that people created. There was this story that Rich and Julio started at the same time. He starts running, then he like drank a gallon of super speed energy drink. He destroys Julio Jones and wins by a full 10 yards in 10 seconds. Come on. And I thought this one was fun. It had a lot of drama. You can see how it sort of plays out and how this student actually did a really good job of showing the winning by 10 yards at the end. You can see those 10 yards. And you can see where he zooms past him, or like, really, did he ever pass him? I think he already was ahead the whole time. The only place they're at the same spot is in the very beginning. And the student also like showed that same thing with their table. We also had somebody who said they both start at the same time. Julio's in the lead, but then he trips and Rich gets ahead, but then Julio goes even faster. Now the tricky part for this is, how would you make an equation for this? It's easy to make an equation for Rich because you can pick a speed and just make him go, like you could create it with the table. But for Julio, there's 3 different things that happens here. There's him running in the beginning, then there's him tripping, and then there's him going, it looks like, even faster at the end. So you'd have to sort of build 3 different equations to show the 3 different parts of what happened. For this one, I think the equations would definitely be an interesting way of representing it, and a smart thing to do. But if I was trying to figure out where he was actually going to catch him, maybe I just need to know that last section, I guess, and look at the last equation with Rich's equation. And then this one had some non-linear stuff for Julio too. He started getting ahead, and then he was like, hey, I can just like play around. I can do flips. I can do skips. I'm still so much faster than Rich that there's no way he'll catch up. So we're just like running the whole time, and Julio's like running away, and then he's like doing all this stuff. Anyway, it was fun. And then somebody else had Rich had a 10-yard advantage, so he was going fast, but then Julio caught up to him. Then out of nowhere, they were tied, but then Rich fell so hard. I think actually this happened. I think Rich fell so hard before the tie happened, because he's still ahead at this time. And then he like falls, and then Julio's still catching up. I don't know how. I don't think that Rich could make it even with a 10-yard advantage, but that's the story. He's still unconscious. At the 30 yards, I like the specifics about where. So Julio wins, and I hope they go out with a stretcher or something. I don't know. So people had questions at the end. Julio is a real person. He's a wide receiver for the Atlanta Falcons. And this clip was, I think, from 2011 when he was like trying out for the NFL. And somebody was like, I had this question about the speed. I was paying attention to it. And when I was like sure about my answer was in the table. I hope you look to see how it was in the equation too. So people had some suggestions for what they'd like to see. They said less questions, more just solving equations. Other people were like, equation solving was really tricky. Maybe like do some linear exponential. Sorry, I'm going to hold off just a little bit. I'm going to post something exponential maybe like Tuesday or Wednesday. But today I'm going to give you just a little more equations practice with equations of lines. And then I'm going to do a little bit of linear inequality stuff. And then we'll get into like some exponential growth stuff. I'm looking for what I think would be a good activity, or trying to like design something that actually would be interesting, and maybe looking at some different simulations. Somebody talked about like letting you choose from the 3. I think it's good to try it out using graph, equation, and table to be like, well, what's the advantage of each? What can you be more specific about, or what's faster or different? But I think it is sometimes useful to be like, well, I don't have to do all of them. Which one would be the easiest to try? It was fun, but I want more fun. Listen to music while doing this activity. Those are great suggestions. A question I have for you, and what I'd like you to respond to this video with, is like, what music have you been listening to while you've been cooped up inside? Let's see, I just started listening to this rapper called Chica. I like watched her like Tiny Desk concert on NPR, and I really liked it. She's got a new album out and called Industry Games, and it's been fun. And then I like what Spotify's suggesting me afterwards. All right, so comment with what music you're listening to now. And I'm about to go post another Desmos activity that's called Match My Line. Bye. Actually, I'll show it to you now. Stop.